So I've got two solutions pulled up here, and I'm also going to post both of these solutions to Moodle. They're the exact same solution. The only difference is the one called marked up, I actually wrote the answer up in advance. And so that's the one I'm going to work off of because the writing is already there, and I'll just explain the writing. This marked up version, because there is so much writing on there, I saved it with the markup, and I'm also going to post that to Moodle. So you'll have both solutions, one that just has the typical solution at the back of the problem, and this solution that also has the typical solution at the back of the problem, but it has my writing up front. We've got 3 bond problems and a note problem here. The 3 bond problems are all the same problem, except the first iteration is a par bond, the second one is a discount bond, I think, and the third one is whatever's left over. I think it's a premium bond. So those are the first 3 problems, and then the 4th problem is a note problem. So here is the par problem. And again, they all look the same. I'm going to read it this time, but I don't think I'm going to read every one of these first 3. We issue $4 million of 6% 15-year bonds on January 1st, paid twice a year. The bonds are issued at $4 million. So we weren't even told this is a par problem. We need to know that because they were issued for $4 million, and the face value, the stated value, the par value on the certificate itself is also $4 million. So we sold it for par value. That means there's no premium, there's no discount. The definition of that is par. So we have a par bond problem here. First, prepare the January 1st journal entry. This one's kind of straightforward. We don't have a discount or a premium on bond payable account. So we record cash coming in for $4 million, and we record a new liability called bond payable for $4 million. Next, for each 6-month period, compute the cash payment and the bond interest expense. I did that up here. $4 million face value times the 6% face value or face rate times 6/12, half a year, every 6 months. So 4 million times 0.06 times 0.5 is $120,000. We need to make an interest payment every 6 months, a cash interest payment to the bondholders for $120,000 every 6 months. And again, since this is a par problem, there's no discount or premium on bond payable in this journal entry. That full 120 is called interest expense. 3, what is the total bond interest expense to be recognized over the bond's life? So it's $120,000. We just showed that right here. The interest expense is $120,000 for every payment. We need to figure out how many payments. It's a 15-year bond paid twice a year. So 30 payments. $120,000 times 30. The total interest expense is $3.6 million. And then 4, prepare the journal entry. Oh, 2 was just compute. 4 is prepare the journal entry. So this is 2 and 4 at the same time. I computed and I prepared the journal entry. This down here looks kind of busy. I guess it is kind of busy. What I've done is for every payment date, I showed the cash amount that's going out of the company, the amortization piece for the discount or the premium. And I even showed up there, if it's a discount we're getting rid of, we add this number. If it's a premium we're getting rid of, we subtract this number. This is a par problem, so it's 0 in this problem. But we'll see this layout in the next two scenarios. So the cash payment adjusted for the premium or discount amortization gives us the interest expense. This is a par problem, so there is no premium or discount adjustment. So the interest expense is also $120,000. We can see this is the same for every single one. I guess I went a little crazy here. There was no need to write them out for all 30 payments, 15 years, twice a year, but I guess I love this stuff. So I wrote it all out, but you can see it's the same thing over and over and over again. We can also answer question 3 by adding all of these columns here. The interest expense, add all of those and all of those and all of those, and we'll also get to $3.6 million of total interest expense. That's the first one. Here is the second version of this problem. Everything's the same at the top. The only thing that changed is the bonds are issued at a price of $3,456,448. So we compare that to face value, and we see we've got a discount. We issued these for a discount. $543,552 discount. We are going to amortize that discount over the payment life of the bond. So it's 15-year bond, paid twice a year. 15 times 2 is 30. We're going to divide that discount by 30. And every time we make an interest payment, we're going to make an adjustment for the discount equal to $18,118. For each period, compute the cash payment, the straight line discount, and the bond interest. So that's what I've done here. The cash payment is still 120. The problem is exactly the same. It's still the 4 million times the 6%, I think it was, times the twice a year. The adjustment for this is a discount. So the adjustment for the discount is going to be added. And this is just a shortcut method. Add the discount, subtract the premium. I walked through the why in all the slides. So sometimes I get to this point and a student will ask, why are we adding the discount and subtracting the premium? That's everything that we talked about in the slides earlier when we were creating the discount on bond payable account and then getting rid of it, or creating the premium on bond payable account and then getting rid of it. All of those steps boil down to this quick calculation. If it's a discount, we add it here. If it's a premium, we subtract it. And that gets us our interest expense. And this is the same for every period. That is 2. 3 says, what's the total interest expense for the bond's life? We've calculated that the interest expense is $138,118. We know we've got 30 payments, 15 years, 2 payments a year, 30 payments. So multiply 138,118 by 30, and we get the total interest expense over the life of the bonds. Prepare the first 2 lines of an amortization table. Oh, first 2 lines or years? First 2 years. So here is year 1 and year 2. First 2 years. We start off with the full unamortized discount, 543,552. I calculated that up here. 543,552. The carrying value is what we sold it for. 3,456,448. It's also the face value minus the unamortized discount is the carrying value. So here it's 4 million minus 525,434 is 3,474,566. It declined because of the 18,118 that we reduced it by, and then we reduced it by another 18,118 here, and another 18,118 here, and another 18,118 here. And this is also going up by 18,118 every payment until we have fully amortized that discount and our carrying value equals the face value of the bond. And then finally, prepare the journal entry. And that's what this is. And I took this right from all the work that I did down here. There's my cash payment. There's my discount adjustment. And here is my interest expense. It's the second version of the problem, the discount. Here's the third version of the problem, premium. The exact same problem, but now we've issued them at $4,895,980 for a $4 million bond. So our premium is $895,980 spread out over 30 years. $29,866 is our adjustment every year. Cash payment is the same. 4 million times, I keep forgetting, is it 6%? 4 million times 6% times a half a year is $120,000. Minus that premium that we just calculated, 29,866 equals the interest expense. For every single one of these payments, it's the same. All 30 payments, the same. And so here is the journal entry. Cash going out, the debit to the premium on bonds payable account, and then plug the interest. And here is the amortization table. We start off with the full premium, slowly whittle it down to 0. And what we see is the carrying value starts off with the full amount that we brought in and slowly makes its way down to face value. I went through that kind of quickly. All of this stuff, though, is in Moodle. If there's no questions on that, let me move to the note problem. And as long as I was doing it, I just did the note problem this way too. think it's more important to do the bond problems because there's a bunch of calculations. I guess there's a bunch of calculations here on the note amortization schedule as well. This is, to me, this seems very, maybe because I've seen a lot of them, so maybe I'm being unfair. To me, this is very structured. And once you get that pattern down, it's not too bad. The problem says, on November 1st, we borrowed $200,000 cash from the bank, signing a 5-year installment note, 8% interest. We make equal payments each year on October 31st of $50,091. So like I told you, we won't have to calculate the payment amount. It's going to be given to you. Fill out the amortization table. So we begin with the borrowed amount as our beginning balance on that first line. The second column multiplies that by our interest rate, 8%. The third column is the difference between our given payment and what we just calculated as our interest. So 50,091 minus 16,000 of interest means 34,091 went to pay down the principal. If our principal started with 200 and we paid 34,091, that means our principal after this payment is 165,909, and that becomes beginning balance for the next period. And then we just start all over again. Multiply it by 8%. Find the difference to get the interest piece, multiply it by 8%. Find the difference between the payment and the interest, and that's the principal payment. Beginning balance minus the principal payment gets us ending balance. Ending balance is beginning balance for the next period. And then find the interest. Beginning balance times 8% is the interest piece. Find the difference between the payment and the interest piece, and that gives us the amount that we have paid to principal, 39,764. Beginning balance minus that principal payment gets us our new ending balance. And that new ending balance is next year's beginning balance. Times 8% is your interest. The payment minus the interest is the principal piece. The beginning balance minus the principal payment is our ending balance. Our ending balance for this year is our beginning balance for next year. And we're almost done. Multiply it. Now you can see I've done some red scratch out. I'll explain that in a second. We're still working with, and forgive me, I'm colorblind. I don't know if I'm saying the colors right. We're still working with the blue numbers. So 46,382 beginning balance times 8% is 3711. 3711 taken from the total payment tells us that our payment to principal, sorry, is 46,380. Beginning balance minus 46,380 leaves us with a $2 balance. We've paid this thing off. We can't have a $2 balance there. So what we're going to do is we're going to force this. I'm going to change highlighter color. We're going to force this balance to be a zero balance. That's what we need it to be, a perfect zero balance. We're going to force this to be a zero balance by changing the interest payment by a couple of dollars. So the principal payment equals our beginning balance, 46,382. And that's the actual bottom line of this amortization table, not the blue numbers that are under there. I showed the blue numbers, we calculate that first, and then if it doesn't come out to be perfectly zero, we go back and adjust those blue numbers with my red numbers in order to force that last ending balance to be zero. And then we can find out, a problem might ask, how much interest did you pay over the life of this loan? How much were your total payments? Here we can double check that we paid exactly $200,000 at principal. That's it.